today. We appreciate it and you making the quick transition as we transition to our Zoom meeting. So everyone is aware we will be recording today's session. So thank you. And I'm going to ask Dr. Shalu if he can forward our slide for me as we get started. So my name is Lindsay Lewis, and I am the Graduate Admissions Counselor for the RIT College of Engineering, and I have likely been in touch with many of you. I am joined today by the Mechanical Engineering Graduate Program Director, Dr. Michael Schrlau, as well as a number of additional faculty you'll be hearing from today, and 3 current graduate students who are all working to complete their degrees. So if you're joining us today, that is because you have been admitted to our Mechanical Engineering Graduate Program. So we want to congratulate you. And today is really an opportunity for you to learn more about your graduate study opportunities. And more importantly, we'd like to hear from you. So please let us know what questions you have, and there will be time at the end of our presentation for some Q&A. So please let us know, keep those questions in mind that you have as we move along. So if we can move to our next slide. So I'm sure that you have all received several communications from RIT regarding our response to COVID-19. And so we won't spend a ton of time on that today, but it is worth noting that if you live outside of New York, that you're likely hearing reports about the situation in New York City. So it's important to remember that Rochester is located in upstate New York and not New York City. We're about a 6-hour drive from the city and have not seen the levels here locally that they are experiencing. Locally in Rochester, I think we have about 1,300 cases reported, but we have a very strong and efficient healthcare system with major hospitals and medical school, and we are currently managing. But we do recognize that COVID-19 is a serious issue, but the situation in Rochester is much better than it is in New York City and many other large cities. So we will continue to follow our New York State guidelines and CDC health guidelines. But with that said, based on the timetables being discussed regionally, we do feel that the fall on-campus opening is likely, and we will continue to prepare to welcome our students to campus. But at the same time, we also can't predict the future. And we recognize that there's a possibility that many of our international students in particular may not be able to complete the process and get their student visas in time to come to campus for the fall. So for that reason, we are developing alternate course delivery options, and we'll continue to provide you updates as they are developed. So as admitted students, you can find our latest information regarding our response on our webpage, rit.edu. The link for our response efforts is in the banner at the top of each page. So just a little bit, if you're wondering what your next steps are now that you've been accepted to RIT, you'll want to take the time, of course, to review your admissions materials. And by joining us today, we hope that we will be able to answer many of your questions and that you'll find RIT is the right choice for you. So as you have hopefully been made aware through previous communications, we have extended our deposit deadline to May 15th and hope that allows you some additional time to review your options. And by submitting that tuition deposit, you're securing your place in the program and reserve your spot for fall. And that also triggers additional steps in the enrollment process and will activate your student account. So with that being said, please feel free. You can always reach out to us if you have any questions about the admission, acceptance, enrollment process. We are happy to help. So with some more information, I'm going to turn it over to Dr. Shalu to introduce himself and our additional presenters and share more information about what you can expect as you begin your graduate studies at RIT.
Thanks, Lindsay. Good day, everyone. I hope everyone's doing well and everyone in your family is healthy. I'm just going to stop sharing my screen here a second and pop in so you can see me. Right? We're live people on the other end, so you can see us. Really today, what I would like to do is just give a brief overview of our program, Mechanical Engineering Graduate Program, and then really spend most of the time talking about the research that we have going on. So I have 5 of my colleagues that have joined me that are going to highlight their research. And that just gives you a taste of the different things that we do in the department. I've also invited 3 of our students in the program. And so you're going to hear from them what they're up to and a little bit about their experience. But more importantly, we are here to answer any questions that you might have about our program. So at the end of it all, we'll open it up for Q&A, and please feel free to ask us any and all questions. Okay, so with that, I'm going to switch back and share my screen. So I'm an associate professor and graduate director here in mechanical engineering. 5 of my colleagues from the department have joined me, and I'll let them introduce themselves when we get to that point. And then 3 students who are right at the end of their program. And there we go. So I don't have to tell you all the good things about RIT. That's why you applied in the first place. But I do want to highlight a few things. So we're in Rochester, New York, which is western upstate New York. And you can see we have a very green space here. And our building is in that circled area there. We're on the 2nd floor of the Kate Gleason College of Engineering building. But that doesn't mean, so that's where our classes and offices are, but a lot of our facilities span across the institute. It's fairly big. So we're right in the heart of the RIT campus. The Mechanical Engineering Department is a direct descendant from the Mechanics Institute, which is where RIT all started back in 1829. We currently have 35 faculty with over several hundred years of combined experience in industry and academia. So there's a wealth of knowledge that you would be able to leverage while you're here. We serve over 900 students, undergrad and graduate students. We have currently 225 graduate students, and those graduate students represent approximately 10 countries across the world. We have 2 degree programs, which I'll get into here in a second. And those 2 degree programs allow you to focus in 9 specific areas, but also there's a custom area that you can self-design for your own interests. Another key thing that we do very well here at RIT is we have a very well-established co-op program. And in terms of graduate students, 98% of our graduate students take advantage of graduate co-op while they're here. And we'll talk a little bit about that. Although our program is designed to be completed within 1 year, so some students choose to do that, most students choose to take about 2 years to complete their program because they take advantage of 1 or 2 semesters of co-op experience as a student here. And we're very proud of our very high placement rate. So 98% of our students find employment or move on to graduate school within 6 months of graduating from our program. So we have a very successful program, lots of experience to take advantage of, very vibrant community, both educationally and research. And that brings me to RIT, but also our department. It's internationally recognized for interdisciplinary research and education, which you're going to hear from some of the people directly. So here's a quick overview of our program. We have 2 programs. We have a Master of Engineering and a Master of Science. So Master of Engineering tends to be desirable to those students who want advanced education and really see themselves moving into a career in industry. For those that are looking for advanced degree PhD or maybe an MBA or something like that, they're interested in research, they choose our thesis option. So about 90% currently of our 225 graduate students are in the Master of Engineering program, and 10% are in the Master of Science. All students start in the Master of Engineering, and those who are interested in Master of Science find a thesis advisor, successfully complete a thesis proposal, and then we simply matriculate you into the Master of Science. There's no need to reapply or anything like that. And any coursework that you did complete in the Master of Engineering applies to the Master of Science. Very briefly, we have 10 courses essentially for each program. Both require 2 math courses. Both require 3 focus areas, which are concentration areas. And then there's graduate electives. And if you're in a Master of Engineering, there's a capstone, 1 semester capstone course. We have a couple options for graduate students. And for Master of Science, it's your thesis. Right? So you can see the similarities and the differences pretty clearly from that overview. In terms of focus areas, so we have some predefined areas that students, if they gravitate to one area, we have a list of courses that fall within that focus area that guide students to check out, register for certain courses. If you find that you don't fit one of those categories, that's okay. We have a custom focus area. So an example, my research is nanobio research. And you don't see nanobio up on that focus area list, but that's okay. My students, some choose thermal fluids or maybe manufacturing or mechanics and materials, depending on their project. But they can also form a custom one where they can design their curriculum. And that's really the power of our program. It's very customizable. We want you to take the courses that you want to take. One other thing I want to mention for accepted students, this is new this year, and I want to make you aware, we are offering online summer classes. We have our 2, so I mentioned both programs require 2 math courses. Those math courses are engineering analysis and advanced engineering math. So we're offering both of those back to back in the summer. So if you're interested, you could take those 2 classes before you even arrive, and they will serve you in all the other courses going forward, because a lot of the other courses that you would take as a graduate student require additional advanced math that you would receive in our program. We also have a course that's focused on MATLAB and Simulink, and that's being offered in the 2nd session in the summer. So if you need to increase or boost your skills in coding and familiarity, this would be a great course for that. And again, this would serve you well in many of our graduate courses as you progress through the program. Another important thing is you all received acceptance letters with a certain merit scholarship assigned. So that merit scholarship will be applied also to anything you take this summer before the original fall entry date. So there's 2 people that you will talk with regularly about the graduate program. That's myself and also my colleague Jill Eamon. So we're here to help you with any questions, help you plan out your courses, talk about options, all those things. We're here to be an advocate for you during your graduate studies. Okay, let's get into some of the research. So as I mentioned, we have several hundred years of cumulative experience in industry and academia. And that ranges everywhere from fundamental studies, fundamental research, to applied research. And so things like fundamental research, like understanding how fluids behave in boiling conditions or on the micro and nano scale, all the way up to how surfaces interact and how surfaces wear and cause friction. And then there's applied research, anywhere from designing biomedical devices or artificial muscles for biorobotics to sustainable energy applications. So there's a whole range, And I'm not going to try to cover it here because you have a few of the experts here that will tell you specifically what they work on, all right? So with that, I'd like to start with our first distinguished professor, and that's Satish Kandalkar. Satish?
Good morning. Thank you, Professor Shalu, for the introduction. It's indeed my pleasure to invite you to come to RIT. This is one of the very exciting schools. I joined RIT 45 years ago, and I go to work every day excited because we make excitement happen there with the students. The area that I am working on is heat transfer and specifically boiling. Now, boiling allows you to dissipate very large amount of heat fluxes. These things are needed, especially in electronics cooling industry. Many students have graduated and they are working in industries such as IBM, Cray Computers, which is now a part of HP, Qualcomm, ZT Systems, IBM, GE, and there they are using the innovative approaches that we have applied in this course. The boiling is really about a bubble, and our lab has been working in that area and we have made tremendous progress. We have world record in pool boiling heat transfer as well as flow boiling heat transfer. And there is a course that I offer in fall on boiling and condensation, which goes into fundamentals of boiling, but at the same time, it introduces you the applications, and you can take this knowledge to electronics industry, to power plants, and many other places. We have extended this work to breast cancer research, and this is 5th year, and we have applied for a patent, and that is an exciting area that is coming up. We are partnering with medical doctors at Rochester General Hospital, and they are providing us with the actual screening with patients. So these are exciting times. Don't let the COVID come in our way. So with that, I'd like to thank you for listening. And if you have any questions, feel free to email me or any of the faculty. You see our email addresses there. Thank you again.
Thank you, Satish. Next, we have Dr. Kathleen Lampkin-Kennard. Kathy?
Hello, everyone, and congratulations on your admissions. So I hope to see a lot of you in the fall. So my lab at RIT is the Bioinspired Systems Engineering Lab. And what we do is we really look at how we can take inspiration from nature to either design biomimetic devices, to design biorobotic devices or different types of wearables, or to use how we can break down our systems into really fundamental pieces that enable us to understand basics about physiological systems that maybe we can't measure or that we can't see. So what I'm showing here are just some examples of things that we do in my lab. So the primary focus is really what you see on the left related to biomimetic robotics. So some of the areas in particular that I'm interested in are soft robotics, as well as the development of novel actuators. So these are things different than your traditional, rigid motors and things like that. I'm really interested in taking inspiration from nature to create actuators that are soft, that really behave a lot like physiological muscles. So we're doing a lot of work in this area and then extending that work to use it for different things like wearable devices or wearable sensors. The other part of what I do is looking at how we can use mathematical modeling, particularly at the microscale, to simulate and understand different flow and transport processes. So what you can see here on the other side of the screen, these are some examples where we're using a combination of in vitro experimentation, simulation, and results from clinical or animal studies to really do comparative analyses between in silico, in vitro, and in vivo to understand what happens at the microcirculation. So these are things where we're looking specifically at transport of biochemical species as well as transport of neutrophils or other white blood cells. Other things we have going on in the lab, down at the bottom, you can see some other examples. I'm also very interested in what happens in underwater robotics. We've also done some work with sports biomechanics, specifically looking at hockey goalies. So I would love to talk more with anyone about this. Feel free to email me. I'm more than happy to set up a Zoom meeting if anyone is interested. So thank you very much and congratulations on your admission.
Thank you, Kathy. Next, we have Roy Liu. Ray?
Hello everyone. My name is Rudy Wu. I'm a assistant professor in mechanical engineering department. So my research mainly focuses on advanced manufacturing. More specifically, one of my research directions is to develop practical two-condition monitoring system. So right now we are collaborating with one company to develop one practical system which can be installed onto the commercial CNC machines to monitor the two conditions, machine conditions or process conditions. For this research, in as you know, in the era of Industry 4.0, monitoring is very, very important and also very fundamental research topics which need to be solved. So we work really hard to develop our own system and also our own algorithm to solve this problem. That is one of my research directions. Secondly, I also have intensive modeling background to use finite element technique to simulate the machining process. In such way, we can fundamentally understand the cutting mechanism and also can optimize the tool geometry, can reduce the machining costs, something like that. And as third research direction, the very new research direction, we also developed some research to fundamentally understand the soft material cutting process. We build our knowledge from fundamental material characterization and also cutting tests to know the soft material behavior in the cutting process, and also to understand the interaction between the cutter and the workpiece material. In such way, we can reduce to cutting force and also optimize cutting process, something like that. Those are the some ongoing research projects I'm doing right now. We are looking for dedicated students can work in our lab. We are looking for masters and doctoral students can join us to develop research in those directions. So if you are interested in my research, please feel free to email me or set up in-person meeting after joining RIT. So I will be more than happy to answer your questions. That's all I have. Thank you so much.
Thank you, Ray. Next, we have Dr. Patricia Iglesias. Patricia?
Hello, my name is Patricia Iglesias and I'm associate professor here in the Mechanical Engineering Department at RIT. First, I would like to congratulate you for the admission at RIT. I came at RIT about 10 years ago, and I decided, or now I feel like Rochester is my home. I hope you can join us too. I'm going to talk about my research, and my area of expertise is tribology. I know that most of you don't know that this word is a new word for you. Tribology is the science and technology of interacting surfaces in motion, in relative motion. And in mechanical engineering or in mechanical system, we do have a lot of surfaces in contact in relative motion. Most of the time, right, we want to reduce the friction between those surfaces in contact. Most of the time, because if you are designing brakes or clutches, you want high friction. But most of the time, friction is something that we don't want because it creates energy losses. So what we are doing in our lab is different ways to reduce friction and wear between surfaces in contact. So one of the method that we are using is developing advanced lubricants or high performance lubricants. Right now, we are concentrated on developing environmentally friendly lubricants based on ordered fluids, and those ordered fluids can form ordered layers between the surfaces in contact and will reduce friction and wear between them. right? And we are experimentalists. Most of our work will be based on experiments. We also do some modeling, and I will talk about modeling a little bit later. But particularly the area of lubricants, we do most of experiments. We use, tribometers, optical microscope, SEM, EDX. So a lot of experimental, techniques to characterize wear and friction between materials. The other, project that we do in our lab is instead of using these lubricants with additive, we use a base lubricant. More likely will be a bio lubricant, and it's a base lubricant. And what we do to reduce friction and wear is introduce texture surfaces, texture on one of the two surfaces. We use different methods like modulation assisted machining, EDM, that is electrical discharge machining, or sometimes also laser, laser to create those textures. And also we experiment to see the differences between having or not having those textures, and we are getting really good results with friction and wear reduction around 60 or 70% in some cases. So that's what we do. In this part, we also do some modeling. So right now we have in our lab 1 PhD student and 2 masters and two master in science and 1 master in engineering. And I'm looking forward to see you on our lab if you want to join us. Here you can find my email, and I would be happy to talk to you a little bit more in detail about this research. Thank you very much.
Thank you, Patricia. Next, we have Dr. Ag Cruces. Ag?
Hi everyone. Welcome to RIT. My name is Agamemnon Cruces. I'm a professor in mechanical engineering. Essentially, 2 areas that I focus in is aerospace systems and systems and controls. For aerospace systems, mostly focus on unmanned aircraft system research or drones. We build drones for companies. We do research for the government related to drones on several projects, and kind of morphing that into also autonomous ground vehicles. For example, we have a project right now to build a robotic ground system, autonomous, that is used to detect gas leaks within ground pipes, and that's done autonomously. So the idea would be to have this robot roaming around areas where there is a known gas leak and to figure out where it is. We also had a project to do that with an unmanned aircraft system, and for things like pipe monitoring and also roof inspections. So the other area that we focus is on controls, and particularly related to drones, on how to make them more efficient through control systems to really try to increase flight time and also save on fuel. So it's very integrated in terms of the controls and also unmanned aircraft systems. And I work a lot with companies as well to, again, perform research related to companies, and working with an Israeli company right now related to developing a new type of navigation system that doesn't rely on GPS. And in terms of students, we have lots of students working on a project. I'm very focused on having the students involved, both at the undergraduate level and at the master's level, to get involved in these projects and have a bunch of funding that we can apply to some of these projects. So if you're interested in working in some of these projects related to drones and controls, come and see me.
Great, thanks, Ag. So I'd like to just take this opportunity to thank all my colleagues for sharing their research very concisely and briefly, but I really appreciate it. My work is focused in nanobiotechnology, and I primarily focus on 2 areas. That is nanomanufacturing, so using templates as a way of integrating nanostructures into larger systems, so for example into pipettes or surfaces, things like that, and then using those manufactured devices for cell applications. So single cells, they're a tenth the size of the thickness of your hair. In our devices, these nanostructures are 1,000 times thinner, smaller than the thickness of your hair. And we use them to probe cells. So we do that for two reasons. We do that for delivering genes into cells, and we also use those devices as sensors to detect disease. So we're really focused on early disease detection before it becomes an issue. So we focus in that. And then we also use our devices for gene transfer, and that has applications in gene editing, immunotherapy. In fact, my collaborators who are at University of Rochester Medical Center and I are working on COVID-19 approaches, treatment approaches using our technology to train cells to fight disease. So we're in that space. We also have other supporting research areas for those two main thrusts. So we have a couple 3D printers in our lab that we use to design and develop custom scaffolds for our nano devices. And we also work on manipulators. Manipulators are a way to maneuver the probes to specifically target organelles and small areas within cells. And so we have MATLAB control schemes and things like that that can do that automatically. And there's a variety of other things. We also do some computational fluid dynamics, where we model this template-based nanomanufacturing process. So we have a very diverse research portfolio, all targeted around nanomanufacturing and single cell devices. So I hope you all enjoyed hearing about some of the research that we do in the department. So just to summarize, we have 2 degree programs to fit your needs. We have our focus areas that help guide you in course selection. We have both theoretical and applied research, wide variety of faculty and facilities here at your disposal, and we really encourage hands-on, right? We have a lot of open access facilities. We want you to get your hands in there and dirty and making things. Again, our program is customizable. We have our co-op program, which most students take advantage of and prepares people well for careers. We have a very expansive professional and alumni network too that can help in your job search, and is just a wealth of knowledge as you're considering career paths. And then again, we enjoy a high placement rate from our graduates. So before I open up for Q&A, I would like to allow 3 of our program students to introduce themselves. These students have gone through our program, are right at the cusp of graduating, and I'd like them to tell you about themselves and their experiences. So first, can we have Advait?
Yeah. Hello, everyone. So thank you, Dr. Shalu, for the introduction, and congratulations to the students for getting admitted into mechanical engineering. So I'm Advait, and I'll be graduating next week. So yeah, I'm in the middle of doing my finals. By the way, our schedule hasn't changed at all in all of this fiasco, because the professors have worked hard and put up all the slides and all the lectures online, and everything is going as usual. The only difference is we are not physically on campus, but our coursework is still going on full force. So a little bit about myself. I'll be graduating next week, as I said before. And I did take the advantage of the co-op program that Dr. Shalu just mentioned. So I was an intern for 2 semesters in Borg Warner Moose Systems. So it's a automotive manufacturing company. And I'm in between 2 final interviews. I'll be deciding on them after my final exams. So again, congratulations, and see you on campus if I'm here. All right, moving on.
Great. Thank you, Advait. Next, we have Kenna. Arcana, are you with us? Okay, just why don't we move on? Let's talk to Nathan.
Hi, can you hear me?
Yep, we can hear you.
Okay, just making sure. So my name is Nathan DeMario. I'm a graduate of the Master of Science program from RIT. I'll be graduating this semester. When I started at RIT, I was looking for, when I was looking at graduate schools, I needed a school that would be flexible in their coursework. I had a master's thesis already in mind that I wanted to complete for a technology I developed in my undergrad. And I also had a unique situation where the technology we developed had a business aspect to it and actually started a company. So I needed a school that was going to be really flexible to the coursework and all of the support that I could get for research activities. And I very quickly, once I got into the school and met the staff, knew I had made the right choice. I was able to tailor my coursework specifically to the dehumidification technology that I was developing. I worked with some great professors that had experience in my field. The technology I'm working on is similar in structure to a fuel cell, and there's tons of great, the professors, they have tons of experience in this area since General Motors used to be doing research in the Rochester area on fuel cells. The experience was phenomenal. I don't think there was a better school for me to pick at all. Just phenomenal experience.
Great. Thank you, Nathan. I'm going to allow Arcana just one more chance here to see if I know she's having some technical difficulties with her mic. Arcana, can you join us?
Hello, Professor Michael. Can you hear me?
Yes, we can hear you. Thank you.
Great. I guess there was some problem with my mic. So, hope you all are doing good. So, introducing myself here, I'm Archana Konka. I'm doing my Master's in ME program. So, same like Advait, I'll be graduating next week. So talking about the coursework, I would say it was always clear to take a coursework in design and analysis, and I should say RIT was really helpful in picking the right courses, which really correlated with my past work experience. And finishing my master's right now, I feel really confident being a professional, both personally and professionally, because I've got a full-time opportunity to join as a structure analysis engineer in Boeing. And yeah, fortunately, it's the same day when I'm graduating. May 8th is my joining date. So I'm totally looking forward for it. And yeah, I congratulate everyone who's looking forward for the mechanical engineering program. Thank you.
Thank you very much. So with that, I'd like to, again, thank all the presenters today. And some of them, if not all of them, will be staying on to help answer any questions that may arise. I'd like to turn it over to all the attendees here and allow you a chance to talk about or ask any questions that you would like. I'm going to stop sharing my screen and I will turn on my video so you can see me again. And if you have any questions, please unmute yourself and feel free to ask. Thank you.
Hello.
Hello.
So can I ask you a question?
Sure.
I'm in India right now. So when is the date to pay my fees?
Lindsay, could you chime in?
I'm sorry about that. Could you repeat the question?
No, I'm actually asking about the date when I have to pay my fees. Mostly the students, they pay their fees through bank loans. So we have to approach the bank.
Lindsay, I think
So I'm not sure. Yeah.
So in terms of so you have your tuition deposit, for which we have extended our deadline to May 15th. So that's the timeline that we are looking at right now. In terms of the remaining of your tuition, your fees, It depends on what you have set up with financial services. Typically those are done in installment payments. So we are definitely keeping an eye on kind of how the global reaction in terms of having services, including banking services, open to our students so they can pay those fees. So we're working with students on an individual basis, to work with you and to accommodate, what is happening within your country. We know this is, it varies from region to region and country to country. So right now, those are the dates that we're looking at. You can reach out to me and I can follow up with you one-on-one, and we can kind of discuss what your options are and work with Student Financial Services to help coordinate that.
Okay, thank you.
Does that answer your question?
Yeah, sure. I'll contact you in person.
Great, thank you.
Thank you.
Welcome.
Hello, can you hear me?
Hi, how are you?
I'm good, how are you doing?
Good, thank you.
My name is Quinn O'Rourke, and I just have a question about the what the Masters of Science program looks over the 2-year schedule. So I think I got a feel with like how the co-op spreads out the engineering, maybe that would work more, but in the Masters of Science, how does that look?
Sure. So typically students interested in the Master of Science program find an advisor and propose their thesis proposal within their first year. And what that allows them to do then is set kind of the plan out for the next, essentially to finish their thesis. We do allow students to go on co-op if they are in the MS program or want to be in the MS program. And that's done in conjunction with their advisor as well. There's many opportunities where faculty have projects with companies, or a student will find a co-op with a company that will benefit their thesis. So we allow for that as well. So it really depends on when you propose. The later you propose, the longer it would take essentially to finish your thesis. But even our thesis students finish within 2 years. Sometimes they might go into the summer after their second year and defend. I think a few of us actually on this call have students in that situation. But usually it's 2 years, maybe an extra summer. And it really depends on the scheduling. And Jill and I, we would work with you on the planning of how all that happened. But the important thing is connecting with the faculty and defending your thesis proposal. And then that helps dictate the rest of the schedule.
Gotcha, thank you.
Mm-hmm. Are you, if I can, are you looking at a certain research area?
Still not completely decided, but I am interested in the biomedical applications of mechanical engineering. So there's a couple areas that fall within that, but that's kind of my general plan and focus.
Yeah, and we're here to help too. I mean, you saw just some of the research here as well, but again, offline, I'd be happy to speak with you and help you navigate some other research areas. One other thing to consider is your advisor does not necessarily have to be in mechanical engineering. So if you find somebody in biomedical engineering and you want to apply your mechanical engineering graduate expertise to someone's research in a different department or a different college, that's okay, as long as it has mechanical engineering basis.
Perfect, thanks.
You're welcome.
So it looks like we have a question that was chatted in by Tejas. What are the career opportunities for international students in the CFD area, especially in electronics cooling area?
Satish, are you still online?
Yes, indeed.
Yes. Would you be willing to address that question?
Yes, the electronics cooling industry is really in a boom here. We have, last year I graduated about 4 master's students, and 3 of them are working in electronics cooling industry. So electronics cooling industry really has a very wide spectrum. You need to have gaming computers or even very reliable IBM racks, which require that. And on the other side, the high-end heat flux end, industry is struggling to dissipate. So there are research opportunities. So as I said, my first PhD student in 2005 is now the director of cooling. He was director of cooling at Cray Research, Cray Computers, which is taken over by Qualcomm. And there are many students who are in that industry. So that's a very, very growing industry, electronics cooling.
If I could just add too, students who focus on computational fluid dynamics, even if it's in a different area, can find themselves employed in, a different area that they learn CFD. So, for example, one of my master's students did CFD for our thermal fluid template-based nanomanufacturing process. He ended up using his skills as a PhD student with one of our colleagues doing vasculature, so blood, heart pumping studies. So having skills, no matter what area you focus on, can help you pivot into different industries. Great question.
Dr. Shalu, I would like to pitch in.
Sure.
I would like, Tejas, I would like to let you know that our campus has career fairs as well, that we have it twice every year, every semester. And if you are looking for opportunities in CFD, or as Dr. Shalu mentioned, in different industries, you could take an advantage of that as well. So around 200-300 companies come every year for the career fair, and out of that, around 120 companies come, 150 if I'm not wrong, last semester came for mechanical engineering. And you can just go and chat to them and look for your prospectives. So again, apart from what our professors mentioned and apart from what Dr. Shalu mentioned, I would like students to know, especially international students, since everyone has a sort of nervousness that what would US job market look like, but a career fair is very vast, and you can just talk to employers and get your feedback from them directly. Thank you.
Great addition, Andy. Thank you.
This is Lindsay again. I will add to that in terms of career services and that RIT, and our focus on real world work experience. I'm not sure if any of those that are on with us today joined us yesterday. We actually had an excellent webinar for our students from our career services office and staff. So if you are interested and you want to learn more about career services and what is available to you, we have a very robust team in place to assist all of our students, both domestically and internationally, to help with your co-op placement, your permanent job placement, and they will be there to assist you every step of the way in your job search, resume writing, interview techniques. So we definitely support our students in their careers.
Looks like there was another question. Is a PhD degree preferred by industry in R&D? Do some of my colleagues want to jump in and offer their perspective?
I can chime in here. This is Dr. Kandlikar. There is actually a demand for both. Now, PhD degree students or graduates, they would go in industry and they would be leading research teams, whereas master's students, they are needed to implement the new technologies. So it is not a regular type of work. It still is advanced, but there is a demand for both. And for every one PhD, there would be something like 10 masters needed, and more like 20 undergraduates. So there is a demand for everyone. And as Dr. Schrlau mentioned, if you know CFD, you can apply it anywhere. You can apply it in electronic schooling, gene sequencing, whatever. So your interest really drives the field. Yes, thank you.
Thank you, Satish. Okay, we're nearing the end of this session, but that doesn't mean that your questions are going to stop. So, before we end, remember you can always reach out to myself, Lindsay Lewis from Graduate Admissions, any of the faculty. You can, you can email and ask specific questions about their research. You'll find that our faculty are very approachable. Love talking about their research, especially with interested people. So, feel free to do that. Is there any last minute questions that anyone has?
I know you mentioned some courses that would be taught online over the summer. Will we be able to take those starting, I think that's in a couple of weeks, or is that like next summer kind of thing?
No, great question. That's this summer. So you can, if you're ready to jump into coursework, we have our 2 math classes back to back. So you can get Math 1 and Math 2 done in the summer. We also have the MATLAB Simulink course being offered for coding and those kind of things. So these are great courses. I think the MATLAB Simulink, if I'm not mistaken, is the second part of the summer. So that's starts toward the end of June. But yeah, you're able to register for those after you matriculate as a student. Again, your scholarship, your merit scholarship that was given to you upon acceptance, you can apply this summer to any or all of those 3 courses.
Wonderful. Thank you.
You're welcome.
Hi, this is Quinn again. On those online classes, is there somewhere we can find some more information of like what the time, how much time dedication those would take, and what the structure of those look like?
So they've just been put on to like our registration system. I believe they're available through to view through the Tiger Center. Lindsay, can you confirm that? Do you know if students can look at that and see courses this summer yet?
Yes, you should be able to see those courses there. So how that would work is that once you submit your tuition deposit, that activates you in our system, creates your student account, and that's where you'll be able to then start enrolling and seeing the classes that are available to you.
I mean, just thank you, Lindsay. Quinn, I think thinking about a 3-credit semester course compressed into 6 weeks, you could imagine, a course right now, just double the time, is a good estimate of how much time you'd be spending on that. And by definition, graduate courses are a little bit more intense and require a little bit more work, but nothing that you couldn't handle. I mean, we that's why we accepted you into the program. So, but in terms of timing, the Tiger Center does have what days and times those are offered, and then the structure of that will come out in the next, within the next week, because this is kind of a new addition, based on kind of the conditions we find ourselves in. But if there's any questions about that, that's why Jill, Eamon, and I are here too. We can help answer those questions either one-on-one. If you have specific concerns or questions about the timing or how you'd access material, we can help you with that.
And this is Dr. Cruces. If you have specific questions about the MATLAB Simulink Advanced Systems course, I'm the one teaching it, so you can email me anytime about it.
Mm-hmm.
Awesome. Thank you.
You're welcome. Oh, thank you, Patricia, for putting the link, the Tiger Center link. So My colleague just put the Tiger Center link, so any student can click on that, or you can Google Tiger Center, RIT Tiger Center, and it will allow you to search classes by semester and by term. So thank you for that. All right, we're just about out of time. Any last minute questions? Okay.
Before everyone signs off, I just wanted to once again reiterate what Dr. Shalu had shared, that please feel free to reach out to us, whether it be through the enrollment office. You can message me directly. We have a live chat option, so you can chat with us live, as well as I know that the faculty is very open to answering any questions that you have, connecting with current students to get their perspective. So please feel free to continue to reach out to us with any questions or concerns that you have.
Thank you, Lindsay.
And I just put my email address on the chat.
Great, thank you, Ag. And we will be sending out these slides to all the students that attended and ones that couldn't, and then also making available this the recording of this Zoom meeting. So again, I appreciate all my colleagues for taking the time to share their experience and talk about their research. The students, thank you so much for taking time out and being with us today. Thank you very much.